SwayamPrabha. Digital India. Educated India.
Hello everyone. Now we will continue with the fabrics used for protective textiles. So, after different woven fabrics what we have discussed, we have designed, now it is a laminated fabric. So, laminated fabrics are basically special type of fabrics which are normally very commonly used for protective textiles. It is basically is made by bonding a thin polymer film. Okay. Like if we have one say laminated one fabric structure is there. So, and fabric is laminated with a thin polymer film which is laminated to give the additional performance. Suppose if we want a breathable fabric with waterproof. So, normal fabrics are say woven fabrics are breathable, the moisture vapor can move through this, but at the same time water can also pass through this fabric. We want a waterproof fabric, but at the same time to enhance comfort the moisture vapor should come out and it should not allow the external water to be penetrated. So, for this type of fabric we have to use a lamination technique. So, normal fabric is actually bonded with a thin layer of polymer film to produce the laminated fabric. The film is bonded on the fabric structure, fabric surface using heat, pressure or adhesive. So, this film is normally bonded on this by adhesive. It can be single or multi-layered for added performance. So, for normal fabric we can use the single fabric, we can use the polymer film to enhance the through as for example, we give the woven fabric and we are using this lamination to enhance the to get the breathability at the same time to enhance the waterproof performance. But if we want the thermal insulation, so in that case what we can do, we can use the nonwoven fabric and multiple nonwoven fabric and one layer can be the treated fabric with the polymeric film, porous film. So, it can be single or multi-layered for added performance. So, here what we are achieving here in this type of structure, we are achieving thermal insulation, we are achieving the waterproof, we are achieving the breathability. So, this all this type of requirements are there for protective textile like fire protective textile. So, we have to design our clothing using the laminated fabric technology. So, production process of laminated fabrics, you have to choose the substrate fabric, maybe cotton, polyester, nylon or blend. So, substrate fabric which provides the strength depending on the intended use. Okay. Now, the thin polymer film like polyurethane, PVC, PTFE is prepared. Here these films are normally water proof, but it has got the pores. So, it is breathable, moisture can flow through this. Okay. The film may be microporous for breathability or solid for full waterproof. So, it can be for breathable application, for apparel application we use this film as microporous film, but for to create a waterproof fabric for say tents or for some different other applications, there we may not need the breathability. So, there it may be solid, this without any pores. So, depending on the application we use the different types of this laminated film. The polymer film is applied to the fabric using heat and pressure, or sometime it is adhesive. So, they are sandwiched with the fabric and film is melted and bonded on the fabric under heat and pressure. So, fabric is or sometime if we do not want melting or bond, so that can be adhesive can be used. Okay. A thin adhesive layer binds the film to the fabric and uses pressure sensitive adhesive at room temperature. So, at room temperature if we apply high pressure, so that will give the nice bonding. That softening agent may be applied to improve the handle and flexibility. So, during the bonding that it should not that adhesive, when if the adhesive is made used, that can be after the after drying it should not get stiff. So, then it will reduce the flexibility. So, to improve the handle and flexibility, the softening agent sometime applied to the during this process. The characteristics of laminated fabrics: the polymer film layer prevents water through this, but it at the same time it allows the wind to pass through this. So, which is actually makes the fabric waterproof and breathable. But if we use the solid film, if we do not need any wind to pass, or maybe we do not need breathable fabric, in that case we can use the solid film. Strong and long lasting due to combined strength of base fabric and the laminated film. So, laminated films are normally weaker than the base fabric. So, base fabric is a stronger. So, that if it combined strength, so it gives the long lasting coated fabric, but the this long lasting, the durability depends on the this bonding characteristics. often has a glossy and uniform finish depending on the type of films used. So, one that side the laminated side remains glossy or uniform. Thin film provide flexible and depth. So, and whether thicker film may reduce the softness. So, thin film is normally used for apparel purposes and thicker film where the other technical applications are there, like your different types of taints and all applications, we may need little bit thicker film where softness does not matter too much. So, microporous films are used to allow the moisture, vapor or air to pass through, providing comfort in the garments. For garment application, as I have mentioned, this microporous films are used. So, there are certain films which provides chemical, oil and stain resistance depending on the applications. So, different types of films can be used. The advantages of laminated fabrics are it provides excellent protective performance against rain, snow and wind. So, for this all these applications we need some lamination. The combination of base fabric and laminated film enhance the strength and wear resistance. Certain laminated films provide resistance to oil, chemical and stain that we have already mentioned, maintains a lightweight compared to multi-layered alternative while offering protection, that is important. So, the laminated film is very thin and it is very lightweight. So, if we if we actually attach this laminated film with the base fabric, which is again not very thick, we can achieve the very good characteristics in case, but in multi-layered alternative, because where the number of layers are more, to get the similar characteristics will be little bit difficult. Like in coated structure, where the coating will be thick, needs to be thicker coating. So, that will make the fabric stiffer and not that flexible. It can incorporate multi-layer for insulation, aesthetic and additional functions like breathability and waterproofness. So, that multi-layered structures we can, as I have mentioned, in for multiple characteristics, multi-dimensional characteristics, we can use different types of layer for different additional functionality. The limitations are its cost is high due to the additional process of lamination. Softness and drape is reduced to some extent as compared to normal fabric. Complex production process, because you have to produce the fabric, then you have to have laminate the film with the fabric, which is a complex process. Potential to delamination, if the bonding is not proper. So, it may get delaminated and that will actually then destroy the performance of the fabric. Limited stretch and special care is required, because of the if it is washed or if it is handled improperly, then it may damage the laminate and which and it may remove the delamination may take place. So, we need special care, normal washing will be sometime difficult. So, the applications are outdoor and military gear like tent, backpack, jackets, parachutes, where we need special characteristics like protective clothing, workwear uniform, and rainwear or maybe fire protective gear, sports wear and active wear we can use this. So, luggage, flags, banners. So, these are the different types of laminated fabric, but here also the for fire protective clothing we can use the laminated fabric. Now, after laminated fabric, now next category is coated fabric. So, coated and laminated are a little bit synonymous, but here there is a little difference is there. The coated fabrics you can see here, the coated fabric is a textile in which polymer or resin is applied directly to the surface of the base fabrics. So, in laminated fabric one separate film of polymer is attached with the fabric. This is the fabric and film is attached by adhesive or by pressure or heat. But in coated fabric the polymer or resin layer is applied on the fabric and then the fabric base fabric and then it is applied and then it is dried to get the coated fabric. Coating integrates with the fabric rather than forming a separate film. So, it does not form the separate film, it becomes a part of the fabric structure. So, there that means like unlike the laminated fabric where laminate can be taken out or delamination may take place, but here coating it is a integrated part of the fabric structure. The fabrics like polyester, nylon, cotton or blends are chosen depending on the end use. So, for different end use we can use different types of fabrics. Okay. Now, polymer or resin such as PVC, PU, rubber, acrylic, silicon are prepared, that resins are prepared and then they are applied. So, they are sprayed over the fabric using a knife blade. So, different types of coating techniques are there, different and they are sprayed over this over the fabric and fabric passes through between the rollers to apply the coating. And polymer is sprayed for lighter and pattern coating. So, the spray coating is also there. So, where the polymer is sprayed may not be in the whole area for a pattern coating or maybe throughout the surface. Coating is dried or cured at specified temperature to ensure strong adhesion to the fabric surface. So, these are the this is the coating process. Waterproof or water resistance depend on the coating thickness. So, it is actually the coating thickness changes the characteristics. Okay. durable and strong due to reinforced fabric layer. So, reinforced surface layer is the actually main reason for durability and strong characteristics. Slightly stiffer than uncoated fabric, definitely it will actually additional coating, polymer coating will make the fabric little bit stiffer, can be textured or smooth depending on the coating type. Chemical and stain resistant is possible with appropriate coating. So, we can use different types of coating to make it chemical or stain resistant. Less breathable than laminated fabric unless microporous coatings are used. So, in coating it is normally it is not pores are not generated, pores are even if it is there it is very less, because it is a polymer directly it is coating. So, it is not that breathable, but in laminated fabric the film is microporous film is created first, then it is laminated, it is actually attached with the fabric surface. So, here the coating microporous coatings are also available, where actually micro pores are created, like your micro bubbles are created initially. So, which creates the micro pores, and that is that technology is because that type of coated fabrics are available, which are used for garment, waterproof breathable garment. The advantages of coated fabrics are it provides protection against water, oil, chemical or stain depending on the coating material. Coating reinforces the fabric surface, enhance the strength and lifespan. It also protects the fabric itself, generally cheaper than the laminated fabric, because the long process and because in the laminated fabric we need specialized process. Here coating is a little bit cheaper, because the polymer is directly sprayed on the fabric surface, but still offers some functional characteristics, functional benefits. Coating can be textured, it can be colored, glossy or pattern, allowing the versatile design option. Easier and faster to produce than the laminated fabrics, as it does not require bonding a separate film layer. So, it is a quicker, it is a easier, because in laminated fabric we need a separate film for bonding. The limitations are it actually reduces the breathability, but in laminated fabric as there are pores are available. So, breathability is not affected. Here it reduces the breathability, it is less flexibility and stiffer because of the coating and the solidification of the coating material, the polymer. Coating may crack or peel over time, so that actually deteriorate the characteristics. Limited stretch unless combined with the elastin fiber. So, that it is true for other type of fabrics. Special care needed to maintain the coating. So, if coating may be peeled off or may be affected by the environment. So, special care needs to be taken. the applications of coated fabrics are rainwater jacket, rainwear jackets, coats. So, there we need coating, bags, backpacks, luggages. So, where we need the waterproof finish, industrial textile, tarpaulin, protective cover. So, all these applications, so for human protection we need coating. So, upholstery, outer for outer application, outdoor furniture. So, there we need coated fabric, protective clothing, workwear, chemical protection. Now, we will discuss the knitted fabrics. So, knitted fabrics are after woven, the next structure, very important structure which is used for protective textile like gloves or some many applications, knitted fabrics are used. So, the knitted fabrics are basically characterized by the loops. So, typically made of interlooping. So, these are the this type of interlooping will be there in knitted fabric. This structure gives the fabric elasticity, softness and flexibility. So, due to the loop structure, so this is suppose it is a web knitted structure, this is the coarse and so this type of interlooping creates the knitted structure, and due to this loop structure these fabrics are elastic and soft and flexible, and it can be stretched in one or more direction. This is stretchable normal web knitted fabrics. If we talk about the web knitted fabric, this is stretchable fabrics. Production process, knitting can be used by the cotton, wool, polyester, nylon, blended yarn depending on the desired fabric properties. So, yarn loops are formed in successive rows and linked to the previous loops as I have shown. So, successive rows of loops are there and yarn runs horizontally in the web knitting machine and vertically in warp knitting machine. So, in web knitting machine the yarns move horizontally and in warp knitting it moves vertically. Okay. The interlacing loops create flexible stretchable fabric. It can produce various texture, patterns, designs such as rib, pearl, jersey, cable knit. So, different types of combination, various textured pattern we can use. Okay. This fabric may be bleached, dyed, printed. So, now the if you see the characteristics of knitted fabrics, stretches in one or both directions depending on the knit type, soft and comfortable. So, if we knit as we have discussed earlier, so for protective textile where we need comfortable fabric, So, and soft and flexible. So, knitted fabrics can be used wherever it is possible without sacrificing the protection level. It falls smoothly and conform the body shape. So, it becomes comfortable. Loop creates smaller air pockets allowing ventilation. Okay. Less prone to create creasing than the woven fabric. So, it does not crease like woven fabric. So, that is why it does not need frequent ironing, can produce plain re-pearled jacquard textured design. These are the characteristics. Now, try to see the advantages of knitted fabric. Excellent elasticity and comfort due to its flexibility, good breathability and insulation due to loop structure, lightweight and soft, easy to produce decorative pattern, wrinkle resistant and easy to maintain. So, we do not need frequent pressing and all this. Okay. The limitations are less durable than woven fabric because of the loop structure and little bit loose structure, prone to snagging or tearing. Can stretch out the shape over time. Okay. So, that it can be actually the shape can be deformed and it is less suitable for heavy duty application. It is for comfort application knitted fabrics are used. For heavy duty application, it because due to the stretch it creates pores. So, for where penetration or cut and all these are required, there we do not, for heavy duty application we do not use knitted fabric because of the structural instability. Can shrink if not properly finished. So, more difficult to sew and handle than woven fabric. So, stitching is difficult. So, applications here apparel, t-shirt, sweater, socks, underwear, active wear, it's and home textiles, bed linen, blanket, cushion, cover. We use the home textiles, sportswear, tracksuit, jackets, leggings and all active sportswear knitted fabrics are used. So, in active sportswear where body movement is very fast, there we do not use the woven fabric, we always use the knitted fabric. So, gloves, hats, scarves, we use this socks and technical textile, medical bandage, okay, elastic strap or industrial knit fabrics. So, different technical on protective textiles we use knitted fabrics. Now, the last segment of the fabric is non-woven fabric. There are different types of non-woven fabrics are used for protective textiles, starting from needle punch, spun bonded, melt blown, nano wave. So, we use different types of non-woven fabrics. So, the non-woven fabrics are actually characterized, fabric is made without making the yarn. So, fabrics are these are textile made directly from bonding the fibers together. This bonding may be of different types. So, instead of interlacing or interlooping yarns, the fibers are laid in the wave or bat form directly, fibers are laid which is consolidated using mechanical, chemical or thermal methods. These fibers are actually consolidated by mechanical method, or chemical bonding is also there, or thermal bonding. Now, there are different types of production process. Fibers can be natural depending on application, or maybe synthetic fibers. High performance fibers are also used for nonwoven fabrics. The fibers are randomly or with a specified direction. These are, they first form the fibers web. So, in random fashion fiber webs are formed, okay, or maybe at certain direction. If we want at certain direction, so fibers can be laid in that but in the form of web or bat. Then fibers are bonded together to give strength and integrity. This bonding can be by mechanical bonding like needle punching, where the barbed needle, this type of barbed needle penetrates through the web, where the intermingling or interaction between the fibers increases and fiber integrity increases. And it can be a staple fiber or maybe continuous filament fiber. So, continuous filament fibers comes from the spinneret directly, and it is laid on a conveyor belt and it forms the web. And this web can be needle punched, mechanically bonded, or maybe thermally bonded by heat calendar, or maybe chemically bonded also. Chemically bonded, this for staple fiber web we sometimes use the chemical bonding. Process like dyeing, coating, embossing, lamination can be applied depending on the functional requirement. So, if we want waterproof, breathable, so we use some laminating film which will provide the waterproofing characteristics along with the breathable nature. The characteristics of nonwoven fabrics, it is lightweight and soft because of the web structure. Directly no yarn is formed, it is a lightweight and soft. High absorbency or water resistance depending on the fiber and bonding method. Because of the presence of large pores, because nonwoven fabrics, typically needle punch nonwoven fabrics, its porosity is very high. So, that can hold a large quantity of fluid, liquid. Okay. So, it absorbs water, porous and breathable, disposable or durable products depending on the application or fiber type or production. Okay. So, its productivity is very high. Even hydroentangled nonwovens are there, that is called spunless nonwoven. We can produce with varying thicknesses and density. It is a low cost and versatile because of the high productivity, the cost is low. We can use different types of fibers. The advantages of nonwoven is that it is cost effective and fast to produce. So, nonwoven fabric is produced at very high rate, like first wave has to be formed, wave forming, and its total width is formed at a and at different width, high width we can form due to that the cross laying pattern if we use. So, we can there is no basically limit of the width, we can produce a very wide width fabric which is suitable for the different applications like geotextiles. And then this the bonding is there, the mechanical bonding by maybe by the needle punching is the mechanical bonding, maybe hydroentangled by water jet we can entangle the fiber, which gives a very unique fabric structure with a soft fabric structure. Maybe by chemical bonding we can use different adhesive to for bonding. Thermal bonding we can use the calendar for heat calendared nonwoven it partially melting, or maybe by through air bending, hot air is passed through the web, which gives a very high bulky material. So, there are different types of technologies available to produce nonwoven. So, which is lightweight and flexible. It can be engineered for specific properties like absorbency, filtration, insulation. So, if we want higher insulation, so we have to create the fabric with more pores. If we need lower insulation, then we can make it compact. So, we can engineer the fabric depending from the same fabric, we can create different high absorbency, low absorbency. So, we can make lofty fabric and compact fabric depending on our requirement, we can engineer the nonwoven fabric. That is why its a versatility is there. Disposable option is available for hygiene and medical use. So, this as the productivity is high, we can the cost of production is much cheaper than the woven fabric. So, the in sensitive applications like hygiene and medical, where we normally do not like to reuse the fabric. So, there for disposal fabric nonwoven is the answer, where we can use the fabric with for high performance, but with a lower cost, strong and durable when thermally and chemically bonded. The limitations of nonwoven fabric are low strength compared to woven and knitted fabrics. So, the strength and structural integrity, dimensional stability is low. So, to enhance strength, sometime we actually use the scream, like this is the nonwoven fabric layer, and we add one scream of woven fabric, very open structure woven fabric, and in between another nonwoven fabric. So, there we can we can enhance the strength. It can tear easily if mechanically bonded, but again if we need, we can enhance the tear strength by adding the woven scream. Open, what is the scream? Scream is nothing but open woven fabric. So, which will give the dimensional stability or tear strength will be enhanced. Limited aesthetic appeal. So, that is why it is basically mostly functional rather than decorative. So, for technical textiles we use nonwoven fabrics, not as a not majorly used for the apparel or fashion fabric or decorative fabric. Limited elasticity is there. So, it can deform easily. Some types are less durable and not suitable for heavy duty application. So, for specialized application we use this nonwoven fabric, otherwise for heavy duty application we do not use, like for protective garments and all this we do not use. The applications are enormous, very wide range of applications are there in nonwoven fabric. In medical and hygiene area, the mask is there and surgical gown, drapes, wipes. So, for mask it is we need multi-layer nonwoven, okay, like needle punch, metal blown combination. So, needle punched fabric is sandwiched with the either nano wave or electrospun wave or maybe melt blown. So, to create the characteristics with a high breathability, but at the same time it is protective from the microbes. Surgical gowns are very popular where nonwoven fabrics are used, the disposable gowns, diapers, wipes. The filtration, it is very widely used in air filtration and liquid filtration due to its unique nature of low pressure with high filtration efficiency. And in nonwoven, main advantage of nonwoven is the it is a irregular pores with a thickness thicker. So, particle when it enters, it gets actually separated by different principles depending on their speed or depending on the size. So, nonwoven fabrics provide most of the characteristics which can arrest different types of fiber particle size, starting from the coarse particle to very fine particles like bacteria or virus. So, that different filtration technologies are there, techniques are there, that we will discuss separately in water and air filtration. In geotextile, it is very widely used in soil erosion control and soil stabilization. Nonwoven fabrics are used because of their high filtration efficiency with which can arrest the soil, we control the soil from erosion, but at the same time it can it does not add the water logging. So, it reduces the water logging, but at the same time it restricts the soil erosion. Automotive interiors where insulation is there, insulation maybe sound insulation is acoustic insulation or thermal insulations are there. So, there we use this nonwoven fabrics in carpets, interiors. So, different applications we use nonwoven. Nonwoven is very widely used in automotive, in interior, household cleaning wipes, table cover, mattress, linen. So, nonwoven fabrics are used in all these applications. And in packaging industries, okay, and industrial applications, the protective gloves, bags, insulation materials. So, everywhere we now nonwoven is used. And we have now come to the end of this session. Thank you. So, in next session we will start with actual real life protective textiles. So, we have understood the different types of basics of protective textiles, and also what type of fibers are being used. We have got broad idea about the yarns or different types of fabrics, woven fabrics, coated, laminated, knitted fabrics, nonwoven fabrics. We have got broad overview, and now from next session we will start the different types of protective textiles and their applications and their various technologies we will use, we will try to understand. And till then, thank you.